So before I go into the 5 reaction types, okay, and we write products, I'm going to quickly recap the forms we might be writing those products. So first we have ionic compounds, and in Science 10 we spent a half a day or so on writing out ionic compounds. So if you predict a product that's going to be a metal and a non-metal, you're going to have to remember to use the charges in that prediction. So you might predict the pairing of calcium and chloride. Okay? If you put calcium, which is a metal, with chloride that is a non-metal, you're thinking ionic. So you go to your table and you look up the charges. Calcium is in group 2, and it's written right on your Science 10 data sheet. That is +2. Okay? Chloride is minus. In Science 10, it's written right in. When you get to Chem 20, you're going to have to remember the pattern for the non-metals. So those charges don't balance. Lowest common multiple is 2. So we need 2 chloride ions to get to -2 to balance the +2. So that's one thing you might see in the predicting products. You might also make a molecular compound. This isn't going to happen as much. You could end up making a molecule like water. You see that in some acid-base chemistry. Okay. When you have a collection of non-metals, you would use those mono, di, tri prefixes that we've already used. In Science 10, you have them on your formula sheet. In Chem 20, you have to know them or remember them. Now, what I really want to highlight before we go through the 5 reaction types is elemental metals and elemental non-metals. If you have an elemental metal, okay, elemental means you just have one type of element. Okay? So you might be told that you have copper. Or the question might say you have copper metal. You might get something, particularly in Chem 20 or Chem 30, that you're told you have a gold ring. A gold ring is just a gold piece of metal. What's key here and what makes it the elemental form is that we just have copper in the top example. We just have gold in the bottom example. All elemental metals are going to come in one and be a solid. So if you have copper metal, Cu, solid, okay, you have a gold ring, gold is Au, and that's going to be a solid, and it's just one of them. Okay. Another really important thing to realize when you have the elemental metals is they're neutral. Okay. Now, we don't write this in. I picked a different color for emphasis. We don't write in 0 charges, but I don't penalize you if you do and show that understanding, or it's more acute to your brain to realize it's neutral. So that's copper neutral, that's gold neutral. Okay? If you're wearing gold jewelry, you don't get zapped. There's no charge to the gold in gold jewelry. Okay? Whereas when you have an ionic compound, okay, there is a charge. Okay. Calcium is 2+, you don't get zapped by it or feel that charge because you've got a negative charge to balance it out. Okay. So that's our elemental metals that are on the far left side of the periodic table. Elemental non-metals. So if you have just some non-metals by themselves, you have just nitrogen, just oxygen, just chlorine. One you're going to see a lot is oxygen gas, maybe written in words. A whole bunch of the non-metals come in pairs, and oxygen is one of them. Now, if you flip to the back of your Science 10 data sheet, you'll see a box. It's the periodic table side. Okay? Polyatomic elements is the name of the box on the Science 10 sheet. Okay? So you don't have to memorize that oxygen comes in pairs. You just have to remember to go to the data sheet and look that up. Now, in Chem 20 and Chem 30, you've got to remember these. Okay? As a shortcut or a reminder to remember these, one of them is hydrogen that's all by itself, and then most of the rest of them make a 7 shape. So 7 up is a cue to try to remember these. If you start with nitrogen, that's atomic number 7. And then oxygen is another diatomic. Fluorine, when you just have fluorine by itself, that's a diatomic. Chlorine, bromine, iodine. Okay? If you start at atomic number 7, it kind of makes a 7 shape in the table. Okay? Those are all diatomic. If you have sulfur by itself, it's S8. There's 2 forms of sulfur, S2 and S8. S8 is slightly more common, and that's what you're going to use, and then P4. So those are your non-metals in the elemental form. It's the blue ones that come up all the time. It's fairly rare, Science 10, Chem 20, Chem 30, that you get the blue S8 and P4 coming up. So this slide is what I'm going to be using when I write products. If it's ionic, I'll do the top. If it's a compound, I'll follow all those rules of those prefixes. If it's just a metal all by itself, I'm going to write it solid, no charge. Or if we get a non-metal all by itself, most of them are diatomics. Okay? You just have the green ones that aren't. So let's jump in and do those 5 reaction types that you need to know for all of your high school chemistry career. The first is called a formation reaction. The format of all formation reaction is that you have elements. So we just talked about those. They could be metal elements or non-metal elements, and they make a compound, either an ionic compound or a molecular compound. So in my first example, I'm going to make nitrogen dioxide. We're going to form this. When we talk about formation reactions, we'll often talk about the products first, because once you know the products, you can figure out the reactants. So nitrogen dioxide, we don't start with the word mono. So we have to make this from the elements. Okay, we have 2 different types of elements. We have nitrogen and we have oxygen. So we're going to have to think of what does nitrogen look like in its elemental form? Because formation reactions, the reactants have to be one element at a time. And you have to think of, do they come in 1s, 2s, 8s, 4s? Okay. We've got a second element. That's the oxygen element in our compound. We have to think of, how does that come? Okay. So the first one is nitrogen. You look on your formula sheet. It says, it reminds you it comes in pairs. Oxygen, same thing. You look on that polyatomic elements. Okay. When you just have the oxygen element, the most common form is in a pair. Now, both of these are gases. So this room is filled with nitrogen gas and oxygen gas. So I want you to get used to putting in the states. All of those blue diatomics I had in the previous slide. So hydrogen gas, nitrogen gas, oxygen gas, fluorine, chlorine, bromine. It's only when you get down to iodine that it starts to turn into a solid on us. So that's the skeleton equation out. Okay. To write some formation, you take each element and you write them separate and you look up or remember whether they come in 1s, 2s, 4s, or 8s. Okay. Then we balance this just like you've learned about balancing. So we have 2 nitrogen, so we have to have 2 nitrogen at the end. We only have 1 product nitrogen, so I'm going to double that compound. That fixes my nitrogen. But my oxygen isn't balanced. I have 2 of them at the beginning, a pair. At the end, I have a green 2 pairs. So that's 4 O's between the 2 nitrogen dioxide. So 4 O's. Okay, if I double my oxygen gas, I get 2 pairs and I get 4 O's and everything's balanced. I've been writing in the 1s that you don't have to, but for clarity, I've been putting them in. So that's our first example of a formation reaction. Second example, I'm going to form an ionic compound this time, calcium oxide. No, ionic compounds have really high boiling points and melting points, so that's going to be a solid. Ionic compounds don't melt to 1,000 or 2,000 degrees Celsius. So then we have to think of the elements that would make up calcium oxide. So first we need to have calcium all by itself in its elemental form. Metals come in 1s and they're solid. Again, and just for emphasis, I'm putting in or reminding you that that's a neutral piece of metal. Plus, we have to go to our next element. We make oxide, so we're going to need the oxygen element, oxygen in its elemental form, and they come in pairs. So calcium metal plus oxygen gas will make the ionic calcium oxide. Balancing, we've got 1 calcium on both sides, but we have 2 O's, a pair of O's here, and only 1 O at the end. So I have to double that calcium oxide to get 2 O's. Doing that doubled my calcium, so now I have 2 calcium at the end, or the product side, and I can double my calcium at the reactant side and balance that. So that's my second and last example of formation reactions. Elements become compounds, either ionic or molecular. The second reaction type really fits with this. It's just the opposite. Decomposition. So you could form something, or you could start with a compound and break it down into its elemental pieces. So decomposition, 1 compound. So that's at the beginning. And I'll do the decomposition of liquid water first. So water has 2 different elements. If you had a compound that had 3 elements, you'd have to break it into 3 pieces. But we have 2. We have the hydrogen element. So you have to think of what form does hydrogen come elementally, and what form does oxygen come in elementally. Those are both nonmetals. Hydrogen is diatomic, and oxygen, it's the 3rd time you've seen it. It also comes in pairs as a gas. So liquid water can be broken down into hydrogen gas and oxygen gas. Balancing this, 2 H's to 2 H's, that's okay. 1 O to 2 O's, that's not okay. So we need to get 2 oxygen on both sides. So I have to double my water to get 2 O's at the beginning. Now I have 2 pairs of H's, or 4. And I can get 2 pairs of hydrogen gas, or 4 H atoms in total. on the product side, and now this is balanced. So that's one example. Second example, I'll do sodium oxide. Really, it's the exact same set of skills. Break it up into its elemental pieces. We just happen to have a metal now. Now, one of the biggest difficulties will be for students looking at the subscripts and the reactants and pulling those forward. Okay? The fact that there's two sodium ions has no effect whatsoever on the elemental form of sodium. When this breaks, decomposes into its elements, you get sodium metal and sodium metal. All metals come as ones. The oxygen element will be the diatomic. It's only after you get the correct formulas that you then look at the subscripts. So now that I have sodium in its proper elemental form, I can balance it. We've got two sodiums, so we're going to put a 2 in front. We've got one O at the beginning, two O's at the end. To fix our oxygen, we're going to have to double our sodium oxide. That now messed up our sodium. We've got to go back and fix that again. Two pairs of sodium, so we now have 4. Now, when you're working, a student will often you might put a line through it and update that subscript. That's fine if you do that on a test. Okay? I'm going to nicely erase that subscript and update it. Put in that 1 that I didn't have to. So we're done the first two reaction types that fit together, and you should think of them as a bit of a pair. You got formation reactions, you got the exact opposite of it, you got decomposition. 3 more types to go. Single replacement, and then we're going to do double replacement next. Okay? They're not opposites to each other, but they have similar patterns. Here we have an element, and it's going to replace an atom in a compound. Let's get a visual out. Okay? My element is going to be copper. Elements just have one type of element in the formula. Okay? Compounds have multiple types of elements in the formula. So that's going to react with an atom in a compound. Silver nitrate is going to be my compound. So we've got our blue element, we've got our red compound. It happens to be an ionic compound. And that copper is going to switch something out. Now this copper starts as neutral. We've got silver plus, nitrate minus. And now we have to think, what will copper replace or switch? So you've got to go to your table and realize what charge copper will have when it forms an ionic compound. Is it going to be a positive ion or is it going to be a negative ion? And when you look up copper, you see 2 positive ion options. Copper is going to be positive when it does the replacement. So copper is going to replace our silver. Okay? Whatever charge the element can have, it's going to replace the same charge in the compound. So what we're going to see is a switch, and I'm going to put an arrow in just to give you a visual of the switch. Okay, our products are going to switch that copper and silver. So let's write out the proper formula units. So we're going to have copper in a compound. Okay. It was neutral. You absolutely need your formula sheet. Okay. Chem 20, Chem 30, Science 10. You never memorize the charges. You look and find the most common charge for copper, which is the first charge listed on your sheet. So you find copper, atomic number 29. It lists +2 as the first charge. That's the charge you need to use. So the copper is going to be right next to the nitrate. Okay. So we've done the switch, the single replacement, but then we have to rebalance the charges. When you switch ions, the charges may not be the same, so the subscripts may not be the same. +2 - 1, that doesn't balance. We're going to need 2 of our nitrates. Plus, okay, what's left over? We bump the silver out, and that's going to come out all by itself. Silver is a metal, so elemental metals are just one solid. So those are the pieces to our chemical reaction. Last little bit, I want to come back to the solubility table that you used, and we can make predictions on solubility. So you have that table on the back, solubility of common ionic, solubility of select ionic compounds. Okay? When you run this reaction, you'll find that the compound needs to be dissolved in water in order to mix the chemicals properly. So how we would run this is copper metal, put a chunk of copper metal into a solution of silver nitrate that's aqueous, that's dissolved in water. We're going to get a precipitate. We're going to get silver metal forming. The copper nitrate, you can use that table to predict that state. And that's what I want to end with. Okay, is that going to form a precipitate also, or is that going to be aqueous? So you have to find the anion first, the negative ion, which is the nitrate. So in the Science 10 table, it's the very first column after the heading column. You see group 1 ions, ammonium, and then nitrate in your Science 10 table. And that is soluble with most things. And what it's not soluble is not copper. So nitrate is soluble with most things, including copper. So aqueous would be the correct state to write in. So that means these ions are going to be nice and clear and soluble. They're not going to create another solid. So there's a fair bit to single replacements. You've got to do the switch. You've got to get the correct charge of the ion after the switch, which is our copper in this case. You've got to rebalance that copper nitrate. And now we've got to balance the whole thing. So we've got 1 copper at the beginning, 1 copper at the end, 1 silver at the beginning, 1 silver at the end, 1 nitrate at the beginning. We got 2 nitrates at the end. So we got to fix that nitrate. 2 NO3s, so I have to put a 2 in front to get 2 NO3s. That messed up my silver. I now have 2 silvers at the beginning. I can put a 2 in front of my elemental silver precipitate at the end. And now everything is balanced. That single replacement is complete. So that's a single replacement reaction. I'm going to jump right into a double replacement because they're the exact same formatting, but we have to do 2 switches instead of 1. We don't have any elements now in double replacements. Okay. Cations in two different compounds both switch places. So my first compound is going to be lead 2 nitrate. I said lead 2 because I know lead has 2 possible charges, so I have to include it in the name. So that's one of my 2 compounds. My second compound is going to be sodium sulfate. Lead nitrate is aqueous according to our table. Okay. Sodium sulfate, aqueous. Okay. Reactants, you'll often be told the states. You won't have to look them up. It's the products that you're going to have to use your solubility table to check. So we're going to do a double switch. Okay. I'm going to put a double arrow. Okay. You don't have to write this arrow in, but this is your visual cue to what happens. The lead is going to take the place of the sodium ion the place of the lead, and then we got to refix the charges. So I'm going to write in those charges as a visual aid so we can do the proper switch and write our products. Okay. This is lead 2 plus. That's nitrate minus. So we had nitrate, which has to be minus, and there's 2 of them. So the anion piece is 2 minus, so that's why it's the lead 2 plus. The 4 plus would have too much charge. Sodium is a group 1 ion, so that's always +1. Sulfate is in your sheet as a polyatomic ion, and that's a 2 minus ion. Okay. So let's start this replacement. I'm going to take the lead, Pb. I'm going to remind myself that's 2 plus. And that's now going to be paired up with the sulfate after we do our first replacement, SO4, and that's 2 minus. That's kind of convenient. We got a 2 plus, we got a 2 minus, so I don't need any subscripts here. +2, -2, they balance each other out. This is in water, so we have to figure out, use our table to know whether this is going to be an aqueous product or a precipitate, a solid. So you find the negative ion first, you find sulfate. Now sulfate, when you go down, is aqueous with most things except for calcium 2 plus, strontium 2 plus, barium 2 plus, lead 2 plus is right there. So sulfate with lead 2 plus is a solid when you go across that column. So I'm going to put an S in. That's our first of our 2 replacements. Second replacement, we're going to take the sodium and pair it up with the nitrate. Sodium is a plus ion, nitrate's a negative ion. So +1, -1, we don't need any subscripts for those. Now I want to make a fairly important or a speed comment. If you find nitrate in your solubility table, I'm pointing to mine on my, this is the Chem 2030 version. If you find nitrate and you go down, there are no nitrates that are solids. And that's really useful to know. You don't even need this table for nitrates. Okay? You see any nitrate, you're writing aqueous every single time. Science 10, Chem 20, Chem 30. And I'm going to start doing that. I see anything that's a nitrate, I'm going to stop checking. You're allowed to check, you have the table, but this just saves you time. So it took a bit. We finally have the double replacement out. We balanced all the pieces. Now we just have to balance the whole thing. Okay. So one lead, 2 nitrates, 1 nitrate. So I've got to balance those nitrates. Okay? So I'm counting these as units instead of individual atoms. So 2, due to our subscript outside the bracket, so I've got to put a 2 out front. So lead is 1 and 1, nitrate is 2 and 2, sodium is 2. Oh, and that green 2 just fixed our sodium. 1 sulfate, 1 sulfate. Good, we're done. We just had one number to put in. That is a totally acceptable answer. I'm going to stick in my 1s for emphasis. So we did a lot of work there. Double replacement, balance the charges, predict the states, balance. That's 4 of the 5 reaction types you need for your high school chemistry journey. 1 to go. Okay. Complete hydrocarbon combustion. This is burning things. Very common reaction. Something you should be mildly familiar with from everyday life. You know, you burn a fuel in your furnace at home. You might have a gas stove at home. You might have a barbecue sitting outside. That's the type of reaction we're talking about. Hydrocarbons are C and H. There are fuels, gasoline in a car or diesel fuel. They're carbon and hydrogen. So I'm going to start with methane gas. This is what probably heats everybody's home in here. Okay. Plus, now we're into straight out memorization. You have to know the other reactant when you burn something. Now you probably already know this. Okay. The fuel triangle might be something that came up in junior high or elementary. Okay. When you burn something, you need oxygen. If you don't have oxygen, you can't have a fire. Okay. Red is the color coding I'm going to use for the memorized pieces of combustion. Okay. Then you get the oxygen when it reacts combining with the carbon, and you get CO2 when the oxygen combines with the carbon. Okay. Then oxygen is going to combine with the hydrogen. When oxygen and hydrogen combine, that makes water. Okay. And if you burn this in an open setting, you get water vapor. You see that on a cold day. If it's minus 25 out and you're driving down the road, you see this fog bank coming out from a tailpipe. That is literally liquid water, water vapor that's just freezing because it's so cold and creates a cloud. Water is a product of combustion. And that's it. So this is just a memorize. It's not a predict the products. You have to know it's CO2 and water. The order you write them does not matter. So if you write water first and CO2 second, that's totally fine. Let's balance this. 1 carbon, 4 H's. Now I made this comment yesterday to help balance combustions. We've got 4 H's. They come in pairs. Okay. To get 4 of these, we have to put a 2 in front. 2 times 2 is 4. Okay. We need this to be an even number, and it is, so I'm good. If it was an odd number there, I would have doubled my fuel and then started over. But I didn't have to. So carbon's done, hydrogen's done, oxygen. This is where you can easily make a mistake because you have oxygen here and here. We've got 2 here and 2 times 1, 2 more here. We have 4 O's on the product side between the 2 products. So we need 4 at the beginning. We need 2 pairs to get 4 O's. And that's oxygen balance. We have a balanced combustion reaction. Last example of this lesson. We're going to burn propene this time. A question could be as simple as C3H6 is burned. I would expect you to know, okay, plus oxygen, CO2, and water. Burned, combusted, reacted with oxygen. Any of those three terms, you're going to do this. So because these are memorized, they're a bit nicer than the single and double replacement because you're not doing work. You're just pulling from your memory. And then we're ready to balance as we've been learning. So we'll start with the carbon, 3 carbons, 3 carbons, 6 H's. So to get 6H on the product side, we would need 3 times 2 to get 6. And then hopefully your brain goes, aha, I remember Mr. Curtis saying if you have an odd number here, it's not going to work out. You've got to restart and double everything. And that's what I'm going to do. I'm going to put a 2 here. It's going to prevent that odd number of waters. So now I have 2 times 3 carbon. So I've got to double my carbon. So instead of that 3, I'm just doubling that to 6. Now my hydrogen is 2 times 6, or 12. So that's going to double my water, and I got an even number now, and things are going to work out. Whenever oxygen is in multiple places, even as a teacher, I often do this visually written out on my piece of paper so I don't make a mental mistake. So let's see, we've got 6 pairs of oxygen. So 6 times 2 is 12, but I'm not done. I'm going to write plus 6 times 1, 6. So in total, that's 18 product O's. I need 18 at the beginning. They come in pairs. How many pairs do I need to get 18? I need 9 pairs to get 18. And I'm done. So that's your 5 reaction types: formation, decomposition. They're exact opposites to each other. You've got single replacement and double replacement that are similar patterns, but they're not opposites anymore. Then last, you have combustion, which is a memorized.